Welcome back to the wonderful world of quadratic equations. So far, we've used finding square roots to solve quadratic equations, and we've used completing the square. Yesterday we worked on factoring, and today we're going to use factoring to solve the quadratics. So, a couple things that we need to do. First of all, we're going to factor each polynomial completely. Okay, second, we're going to set each factor equal to 0. Okay, are you writing this down? Because this is important stuff. And lastly, we're going to solve for x. Okay, so let's take a look at the first example. First example is m squared minus 31m. Not a trinomial, and it's not difference of squares because 31m isn't a perfect square. So, going to be the greatest common factor. So what can we take out of both of these terms? It looks like here we have two m's, and here we have an m and some numbers. So we're going to be limited to taking out an m. Okay, if we divide the first term by m, we're going to get m, minus, if we divide the second term by m, we're going to get 31. Okay, now we want to set each factor equal to 0. So m equals 0 and m minus 31 equals 0. This one's already solved. And if we add 31 to both sides, so is this one. So we end up with m equals 0 and 31. Okay, moving right along to the second one. Okay, this one has some big numbers, so if we stop and think about what goes into this one, 64 is 8 times 8, and 200 is 8 times 25. Okay, so it looks like our common factor is going to be 8. So we can take out an 8, and it looks like a u. Divide the first one, and we're going to get 8u. Minus, divide the second one, and we're going to get minus 25. Both of those are set equal to 0. Now let's set each of these two factors equal to 0 individually. So we get 8u equals 0, divide both sides by 8, and u equals 0. And then we have 8u minus 25 equals 0. So we will add 25 to both sides, and then divide by 8. And it looks ugly, but the answer is going to be u equals 8 and 25 eighths, or 0 and 25 eighths. Okay, let's take a look at the next one. Now this one's a trinomial, so this one we can use our chart on. Right, we want the factors of the outside, so 1 times negative 22, that adds up to the middle, which is negative 21. So if we start with 1 and negative 22 and add them up, that gives us the negative 21 we're looking for. So, since this is a simple trinomial and we don't have a coefficient in front of the y, we can put these right into the parentheses. So it's going to be y plus 1 and y minus 22 equals 0. Set each one of these individually equal to 0, so we get y plus 1 equals 0. And y minus 22 equals 0. We're going to subtract 1 and get y equals negative 1. We're going to add 22 and y equals 22. So our final answer is y equals negative 1 and 22. All right, let's look at another trinomial. Okay, so starting out with our chart, we want the factors of 1 times 4 that add up to 4. So the factors of the outside that add up to the middle. So 1 and 4 is going to give us 5. 2 and 2 will give us 4, which is what we're looking for. So we've got x plus 2 times x plus 2 equals 0. You can also call this x plus 2 squared, like when we had the completing the square. Okay, so we're going to set a factor equal to 0. You can set both of them equal to 0, but you're going to get the same thing, so probably 1 is enough. We're going to subtract 2 from each side and we're going to end up with x is equal to -2. Okay, let's take a look at example 5. This looks like it's going to be another perfect square trinomial. So we've got half of 10 is 5, squared is 25. So half of 10 is 5, and squared gives us 25, so we can say x plus 5 squared equals 0. Now that's what this one over here could have been, x plus 2 squared equals 0, and we just took one of them. So this one, same thing. We're going to say x plus 5 equals 0. We're going to subtract 5 from both sides, and final answer is going to be x equals -5. All right, let's take a look at this one. So now we're solving for d's. Over here, this is probably going to be a v. So when you do the IXL, make sure you use the right letter, if it even asks you for that. Very easy to do. Okay, so for this one, we can start our chart. And we've got factors of the outside, so 1 times 121, that add up to 22. Okay, now this has a lot of factors, but I just so happen to remember from our perfect square contest that 121 is 11 times 11. And if we add those up, we get 22, which is what we're looking for. So we have another perfect square trinomial. Half of 22 is 11. Squared equals 121. So we can say x plus 11 equals 0. Whoops, squared. And again, this is supposed to be a d. Automatically, I change them to x's without even thinking, but we're going to set d plus 11 equal to 0. We only need one of them. And then we're going to subtract 11 and get d equals -11. And that's going to be our final answer. Now, personally, I don't care if you change the variable, but on IXL, they're a little pickier than I am, so be careful when you're putting those answers in. Okay, now this one looks a little funny because, first of all, unlike the other 6 before it, it's not set equal to 0. To be in standard form for solving, we need to move this over. So we're going to say 10u plus u squared minus 24, or whoops, minus 24 equals 0. Okay, still looks a little funny, partly because the first term is in the middle. So let's switch these around too. Okay, u squared plus 10u minus 24 is equal to 0. Okay, now we can set up our chart. So we want factors of the outside, so 1 times -24, that adds up to the middle, which is 10. Okay, so we can start with 1 and -24, which is going to be -23. That's not going to work. So we can do 2 and -12, which gives us -10. That one has the right number with the wrong sign. So let's say -2 and +12, and then that one's going to work. Okay, so we can put them right in the parentheses, so we have u minus 2 times u plus 12 equals 0. And then u minus 2 equals 0, and u plus 12 equals 0. Now, I don't know if you've noticed or not yet, but when we set these equal to 0, all we're doing is taking the opposite, because we're doing the opposite to move it over. So if we have y plus 1, our answer is -1. If we have y minus 22, our answer is +22. So looking at these, u minus 2 is going to be u equals 2. And u plus 12 is going to be u equals -12, which is the same thing if you went ahead and set them equal to 0 and solved. So u is equal to 2 and -12. Okay, we have one more, and this last one is a toughie, because this one is a complex trinomial. So we're going to start out with our chart. 12 times -4 is -48. And we want factors that add up to -47. Factors of the outside that add up to the middle. So we can start with 1 and -48. When we add those together, we're going to get -47. Yay, we got the ones we were looking for. Now, if we didn't have this 12 here, then we could say t plus 1 and t minus 48 and be done with it. However, because we have a 12, that makes this a complex trinomial, and instead, just like we did yesterday, we're going to take these two numbers and we're going to rewrite the middle term. So it's going to look like this: 12t squared plus 1t minus 48t minus 4 equals 0. Now we have four terms, and whenever we have four terms, we're going to use grouping. So we'll put parentheses around the first two numbers and the last two numbers. From the first two, the only thing I can factor out is a t. So I'm going to bring out the t, divide this term, 12t squared by t, and we get 12t. Plus 1t divided by t is just going to be 1. And that's what we want our other factor to be also. So we'll go ahead and write down 12t plus 1. And negative 48 divided by 12t is negative 4. Negative 4 divided by 1 is also negative 4. So we're going to put a negative 4 right there. And then we're going to write down our common factor, which is 12t plus 1, and cross it out. And then we're left with t minus 4. Now all we have to do is set them equal to 0. So 12t plus 1 equals 0. So we're going to move the t over, that's negative 1, and divide it by 12. Negative 1/12. Let's do that. 12t minus 1 is equal to negative 1, and then divide by 12. And we get t is equal to negative 1/12. Okay, t minus 4. If you remember, we take the opposite. So we're going to get t equals 4. So our final answer is t equals negative 1/12 and 4. Okay, and that's all there is to factoring and solving quadratics. So this week we've gone over the quadratic formula, factoring, and solving quadratics. Last week we went over completing the square and finding square roots. Don't forget, we have a quiz over all of that stuff tomorrow. All right, good luck.